Okay, so let's get right into it. We're going to be exploring a really big breakthrough in weather forecasting, one that's specifically designed for our, well, rapidly changing climate. It's a story about a new kind of AI that's trying to see storms coming, even in places that have been completely left in the dark.
And the reality is, it's something we're all seeing. Dangerous weather is on the rise. From those sudden deluges to really devastating floods, these extreme events are just happening more often. And that creates this urgent global need for better, faster, and way more accessible warning systems.
So to provide those life-saving warnings, meteorologists rely on a special type of forecasting called nowcasting. Now, this isn't about what the weather is going to be like next week. Nope, this is all about predicting with incredible detail what's going to happen in the next few minutes up to the next 6 hours. It is the key to getting ahead of a flash flood.
But, and this is a big but, this critical tool, nowcasting, has a huge problem with how we do it today. There's a fundamental and pretty dangerous gap in our ability to see what's coming for millions and millions of people.
See, accurate nowcasting depends almost entirely on these dense networks of weather radar. But if you look at this map, you can see that huge populating areas in South America, Africa, and Asia, often the places that are most vulnerable to climate extremes, they just don't have them. They're basically flying blind.
So this really creates two critical gaps. First, you've got the accessibility gap. Think about a city like Rio de Janeiro. It gets hit by floods over and over again, but it doesn't have the radar to give people those precise warnings they need. And then there's a trust gap. A lot of the AI models out there are black boxes, right? They just spit out an answer, but forecasters can't see the logic. And a lot of the time, that logic doesn't even follow the basic laws of physics.
So we've got a gap in radar and a gap in trust. This is exactly where a new model called Tupan comes into the picture. Its goal? To solve both of these problems at the same time, and it does it by using data that's available to everyone, everywhere. Satellite images.
And what's really cool here is just how different Tupan is. A standard AI just learns by looking at thousands of pictures of storms and just tries to copy the patterns. Tupan, on the other hand, is physics-aligned. It's not just learning what a storm looks like, it's being taught the actual physical principles of how a storm moves and changes. It's a glass box, not a black box.
So the crucial point is this. Instead of making one giant, complex guess about the future, Tupan breaks the problem down. It breaks it into parts that a real meteorologist would recognize, things like the storm's motion and how its intensity is changing. It kind of thinks more like an expert.
So how does this actually work? Let's take a look at how this process builds a better and way more trustworthy forecast step by step.
Okay, so Tupan works in three main steps. First, it looks at recent satellite images to figure out how the storm is moving. Then, a really powerful transformer AI, which is a type of AI that's great at understanding sequences. It projects how that movement and intensity are going to evolve over the next few hours. And finally, it takes that prediction and literally reconstructs the future weather frames.
And this, right here, this is the secret sauce. The AI isn't just learning on its own. It's being actively coached. It's trained to produce motion fields that look and act just like the ones from traditional, trusted numerical methods. It's basically forced to learn the physics the right way.
Now, that all sounds great in theory, right? But does this new approach actually work in the diverse and, let's be honest, chaotic weather of the real world?
Well, to find out, researchers put it through a really demanding global test. They evaluated it in 4 completely different and challenging climate zones, from the rainforests of Manas all the way to the high-altitude storms of La Paz. And the results were pretty striking. If we look at Rio de Janeiro for the most dangerous, extremely heavy rainfall events, Tupan was way more accurate than other leading AI models. This chart here shows something called the Critical Success Index, or CSI, and basically higher is better. Across the board, Tupan consistently delivered the best or second best skill. And this is where that trust gap really starts to close, because Tupan's logic is physically sound. Forecasters can actually look at its reasoning, its motion fields, and it just makes sense to them. It looks like what they'd expect to see, which is a huge step for getting these powerful tools actually used in the real world. But wait, this is where it gets even more interesting. The model showed this incredible ability to transfer what it learned. So the researchers took a version of Tupan that was only ever trained on weather data from Rio.
And they tested it on Miami. And get this, it was actually able to improve the forecasts for rare, high-intensity rain events there. This proves it's not just memorizing patterns, it's learning the fundamental physics of weather that apply everywhere.
Building on that discovery, they found that if they trained a single unified TU-Penn model on all the cities at once, it got even more powerful. By seeing a wider variety of climates, it learned more general rules about how weather works, which improved its performance for everybody.
So, what does all this research and data actually mean for people on the ground? For communities that are in the path of a storm?
Well, first off, it's incredibly fast. The entire system can go from downloading the latest satellite data to generating a whole new 3-hour forecast in less than 3 minutes. When a flood is on its way, every single minute counts.
And this isn't just some academic exercise. TU-Penn is already being used operationally in Rio de Janeiro. It's helping the city's environmental agency prepare for floods. So it's bringing this technology right back to one of the vulnerable places that inspired it in the first place.
And that really gets to the heart of this whole mission. The ultimate goal here is to provide equitable access to life-saving weather information. It's about building a foundation to protect communities in those radar-sparse regions that have, for way too long, just been left behind.
Which really leaves us with this final thought. As our world faces more and more climate extremes, innovations like TU-Penn show us how transparent, physics-aware AI can help us do so much more than just predict the future. They can help us build smarter, more resilient tools to actually prepare for it.